Welcome to New York Section of SME, the Society for Mining, Metallurgy, and Exploration, an international society of AIME of more than 13,000 professionals serving the minerals industry in more than 100 countries. Today is December 8th, 2020. Thank you for attending NYSME's virtual symposium titled Strengthening Critical Minerals Supply Chains in North America, featuring the key role of Quebec. This panel discussion is titled, How do industrial and consumer demand drive the need for more critical minerals? The panel moderator is Ken Hoffman, McKinsey & Company's global co-leader of its electric vehicle battery materials unit, and is a senior expert for McKinsey's Basic Materials Institute. The panel will now begin.
Welcome everybody to this panel on how does industrial and consumer demand drive the need for more critical minerals. My name is Ken Hoffman. I am a senior expert here at McKinsey & Company. I run our global EV battery raw materials group, and we sort of look at everything from the mine site through battery technology, but obviously looking at the entire value chain. And 2020, if anything's been interesting in terms of how we look at batteries, raw materials, cost. We've had Tesla Day in the background, as well as so many different things going on in the marketplace with the election of a new president in the United States and so many other aspects around the world. So there's so much to talk about today, and I'm very excited to have a great panel, which will go through this with us. Let's start by having everyone introduce themselves. So going on the screen here, Adrian, could you please introduce yourself briefly?
Hello, thank you, Ken, and thanks for the opportunity to be here with all the panelists. My name is Adrian Tylim. I represent Blue Solutions, a subsidiary of the French group Moderator, an industrial group highly diversified, and I lead business development of our solid-state battery energy technology in the Americas.
Hi there, my name is Adrian Panayi. I'm the Managing Director of RhoMotion. RhoMotion is a research and consultancy house based in London, and we track every electric vehicle that's in the market and look at various factors within that vehicle which will affect the discussion today, principally pack size and battery chemistry, and hopefully we'll get into some of those topics later.
Hello, I'm Patrick Gervais. I'm the Vice President of Marketing and Communications for the Lion Electric Company. We are a leader in building 100% electric heavy-duty vehicles. We build commercial trucks from class 5 to 8. We also have school buses and also building shuttle buses and small transit buses for urban cities.
And last but least, Michael.
Hello, my name is Michael Maten. I work at General Motors in the public policy group. My area of expertise is electric vehicles. I cover both kind of the demand side and supply side of policy around electric vehicles and electric vehicle and battery production. Thanks.
Great, and I'd like to start with Adam, taking it from a big picture. Where do we sort of stand in consumer industrial demand for advanced battery technologies, and how has 2020 played out other than COVID, I guess, which is a big one, and where do we go into 2021?
2020 has been a strange year really for the market that we principally look at, which is the electric vehicle market, because on the one hand you had the initial impact, which was a fall in consumer demand for big ticket items, but then really, the opposite has been true since the worst of the impact in the first lockdown. So that was sort of January, February for China, and then later months for the rest of the world, because it's effectively legitimized national governments' involvement in this market in a bigger way than they would have been able to previously. So, as an example, in Germany, there's been a massive increase in the rate of subsidy that you can achieve when buying an EV. And as a consequence of that, since the first lockdowns really in the Western world, we've seen a massive increase in the rate of sales this year. The other things we've also seen is developments in battery technology as well, in terms of the share of various battery chemistries. And that obviously has a key knock on for specific material demand as well. Perhaps we can go into that in more detail later, but that's been really the main thing, is that COVID has had this initial impact where it had a detrimental impact, but subsequent to that, the involvement in governments in this market has really driven the market forward for the rest of the year.
Now, Adrian, you're sitting in Europe, at least Bolloré is sitting in Europe. How do you sort of see this year playing out? Did 2020 alter how you see the market progressing, or is it more driven by policy, or is it more driven by the technology that you're coming out with?
A good question. Thank you, Ken. So 2020 has been actually a really good year for Blue Solutions and Bolloré. As a reference, we're the only manufacturer of all solid state batteries, and solid state batteries right now are the focus of literally $1 billion of investments from OEM and battery manufacturers. So for us this year, we're able actually to consolidate our business after 20, 30 years of R&D and having developed the third generation of our solid state module. We had a major OEM, Mercedes-Benz, Daimler, the picture behind me, who actually has released the use of our all solid state batteries, in essence, confirming our prediction of where the market is going. So we see that with other OEMs moving forward. We see a huge demand and focus from a development point of view of the battery itself, which is what we make. We believe that there will be more focus, more research, more development. It'll take a few years for competitors to get to where we are for various reasons, and just the way that history developed in terms of solid state batteries. But we think that that's where the market is going towards, and not the least because of the safety of the technology vis-a-vis the current lithium-ion technologies.
Now, one of my old hedge fund terms was optionality. And first off, Patrick, congratulations on your going public. But also, could you talk a bit about, you've sort of created optionality in the creation of your buses. You working with BMW, working with Romeo, you do your own batteries. How do you sort of look at how you sort of choose batteries, how you look at technology, and what's going to drive your demand going forward?
Yeah, I mean, electrification of heavy-duty transportation is just at the beginning, and it's an amazing market to build on. And obviously, batteries are the heart of the heavy-duty vehicles. So we, in the past, have made the decision to assemble our own battery packs. So right now, in the future for us, it's having our own manufacturing battery facility where we would be building modules and assemble battery packs and getting, obviously being cell agnostic and using tier 1 supplier to make sure that we're going to be able to perform and improve our technology. Right now, the technology that we're going to be using in that manufacturing will be 21700 cells. But I mean, there's so many opportunities to come in the future. I mean, we're specialized in the mid-mile market. It's a $110 billion market in North America. So we see the future to be really bright, and hopefully putting all of our expertise at the benefit of this beautiful market. We have over 5 years with over 300 plus vehicles on the road with 6 million driven miles. So we are looking forward on working with all of you guys to bring our costs down, but there will be a very much need for the market in the future. That's for sure.
Now, Michael, I remember a number of years ago when the wind and solar industries were sort of pretty new, and government subsidies meant an awful lot. And some people had said, "Oh, government subsidies will always be there, and they're not going to really see cost improvement." But obviously, in wind and solar, that's happened. To which they're among the lowest cost energy sources on Earth. You speak a lot with government officials in the U.S. We're going to see a new administration. How will government policy play a role in terms of driving forward industrial and consumer demand for these battery technologies?
Yeah, thanks, Ken. I think government policy has a big role probably on both the supply and demand side. We still think there's a need in the light duty market, especially for consumer incentives, and at least a need to maybe level the playing field, so all companies get equal. With the way the policy is structured right now, back from 2009, is that it really penalized us and Tesla as the first movers in the market, and puts us at a pretty substantial disadvantage for the next couple of years in the U.S. market. So costs have come down incredibly on batteries, as you stated. We still have a ways to go, clearly. So we believe incentives are needed in the next, at least the next couple of years, to really jumpstart the market, get consumers comfortable with purchasing EVs and comfortable that they'll fit their lifestyle. So we really see in the next couple of years, a greater availability of vehicles at a greater range of price points, longer range. So all of that's going to combine to really cause the market to grow fairly rapidly here in the U.S. We hope to be a part of it. On the demand side, or I'm sorry, on the supply side, there's also policy needed to ensure that the battery manufacturing and supply chain development occurs in the U.S. That's a key factor to making these vehicles and making a robust, sustainable industry. We've committed to making battery cells here at a new factory in Lordstown, Ohio, that's going to open, our joint venture with LG. But we need those the support to get those raw material supply chains built up as well, and that's an area of policy can really help also.
Yeah, it's funny, we talk about markets. I mean, markets have been a bit schizophrenic. Remember 2-3 years ago, lithium prices were spiking, cobalt prices were spiking. I remember at a conference of one person, someone was buying a lot of cobalt, and they said, "Oh, is cobalt at 100,000 a high price?" And they said, "No, we're in a new price discovery. We just don't know." And the old commodity adage of high prices is the cure for high prices ended up occurring. But now we're after a couple of years of sort of settling down, it looks like things are getting better again. And the number one question we're getting is, costs are coming down very, very substantially. It looks like this is real. Do we have enough materials? Adam, how worried are you that the industry is continuing to drop costs in technology, but we'll just simply run out of raw materials?
Yeah, it remains a concern. I mean, if you look at the lineup for virtually every raw material that goes into these batteries, so key ones being lithium, nickel, cobalt, manganese. With the exception of manganese, really, if you look at the lineup of all the projects coming on or the capacity expansions, you tend to start to run out of material from about 2027, depending on the material. And so you wonder, okay, well, where does that all come from? Now, you can assume that, as you described, that as you start to become nearer to exhausting some of those capacities, that the prices start to go up, and then investment projects that were previously untenable become tenable again. But then you have to factor into that the fact that you have long lead time for development of all these projects as well. So it's a tricky one, because it's sitting there on the horizon, and it's almost, you have to close your eyes and just hope it doesn't happen. But as we all know, hope is not a great strategy for anything. So there's still a lot of investment to come, and it's not even just on that raw material side as well. There's still quite a bit to happen in the processing piece, at the cathode and the anode stage as well. And even if you go all the way down to charging as well, there's a lot of money that needs to be spent there.
Yeah, it is interesting. I mean, and this is something to watch, and it is the question we probably get more than anything. I mean, we are quite constructive on nickel because we think that's probably going to be one of the harder things. But if we did look back, I think the cobalt industry supplied a lot more cobalt than people thought coming into that price spike. The lithium industry, did a lot more. There was a lot of people who looked pretty stupid on lithium. It's sort of interesting to see what's going to happen next.
I guess the issue is that the volumes are going to be so much larger than they were, in that last sort of peak and drop. you know, the EV market barely even started and still really is still in that first mode. So when you're talking about 10 million, 20 million vehicles, the order of magnitude between availability and demand is, you know, that's a bigger, much bigger.
Each wave gets bigger.
Exactly, yeah.
Now, because of that, Adrian, how do you secure your raw materials? Are you securing your raw materials for your batteries? Do you let your OEM supplier secure your raw materials? How do you sort of want to work with the mining community? Do you just toll process somebody else's materials, or do you buy the materials yourself? And how do you secure those materials if we do see this big surge?
Yeah, so it's a very good question. So the way we look at it, first of all, the design of the product is very different than what we know in terms of battery cells. So traditional cells that are embedded in the skateboard of a car, a passenger car, or even trucks or buses are cylindrical in shape. Our design is totally different. It's based on a plastic extrusion technique. So the cell itself is a planar cell, about 1.5 feet by 3/4 of a foot across, and then millimeters, if you will, in thickness. And that's we put into modules, and that's what becomes our cell. So from the design early on, one of the things that we try to do is to find ways that we could have a sustainable battery production through the life cycle of the product. So we develop a recycling, and we're probably talking about this, but it's a recycling process. And we actually, from the get-go, design a product that is not using a lot of these politically or socially impacting materials like nickel or cobalt, for example, even rare earths. So our product is mostly based on a lithium metal, which is in terms of supply chain that you're talking about. We source it at the corporate level. We believe we are one of the largest, if not the number one, global buyer of lithium metal for batteries. In North America, where we have one of our 2 factories, we would prefer to have it locally sourced, perhaps from Quebec. There is lithium, right? The issue is that the refinement of the lithium increases the cost significantly because of the electrolyzing process needed. So we do it at a corporate level. We buy large sources. We right now are sourcing it out of Asia. We'd like to have it locally, and particularly in Canada or Quebec, where there is very cheap cost of energy to be able to produce the lithium metal that we need.
But Adrian, you are actually buying the materials. You are sourcing them yourselves. You're not having your end-use customer source them.
That's correct. That's correct.
Patrick, you're sort of in both camps. You are OEM and cell maker. How do you look at this, or do you? How do you try to figure out, you know, how am I going to have material? I know we'll probably get into the point where governments are sort of asking you for what is the carbon footprint of everything you buy, what is the SO2, what is the water usage, acid, etc. How do you look at your sourcing strategies to make sure you'll have the material you need for your buses you're selling?
Well, the plan is to have our own, like I was saying earlier, battery manufacturing facility here, hopefully here in next to our headquarters in Saint Jerome. And then in North America, we're gonna have growing capacity of, you know, right now we could produce 2,500 vehicles, and we're building a new facility where we're gonna be able to build 20,000 vehicles. You know, the battery that we're gonna be producing are from modules to assemble the battery packs. We're not gonna be doing the cells ourselves. We're gonna buy them from tier 1 partners, just you know, like the partnership that we've done with BMW, with Romeo Power, and with LG Chems, but we're all open to new possibilities. We strongly believe that we're going to be the biggest purchaser of cells in North America in the coming months, years. So with the production capacity that we have. So we have developed our own battery management system, thermal battery management system, sorry. And we assemble our own packs. But this is to be agnostic on the cells. As the technology evolves, we're going to be able to adapt, but also being able to module our battery packs to fit our vehicles to reduce the cost. We strongly believe, you know, without subsidies, that we could reduce from 50% the cost of our vehicles in the next 4 years by having our own battery manufacturing facility.
So I guess two follow-up questions. One, it is, I guess you are not going to say the mine source to source the raw materials for those cells. And number two, if you don't, and that's being taken care of by your cell provider, what type of assurances do they have to give you that you can go to the government and say that this was ethically produced, use low CO2 footprint, et cetera? How will you do that purchasing part?
Well, I mean, we hopefully, right now, all the cells comes mostly from Europe or outside North America. We hope that one day we're going to have a player that will establish itself in North America, because obviously for sustainable, for the economy, for it's going to be much better, and we're going to be much more competitive also, because if we have a partner that we can work, which is closer. We have over 100 engineers full-time that are working on developing our battery management system and our battery packs. So being close to someone here in North America will definitely give us an edge on the market.
I would assume that, Patrick, you and Adrian, you will probably be responsible for what happens to these cells at end of life and the recycling or reuse period. Is that, do you think, where government regulation is going? And Michael, I'm sure you would like to add in as well.
Well, the government regulations is obviously helping. That's, it's going to help to speed things up in electrification. So we're raising our hats to that. I think there's there's a big hype on electrification right now, and for the good reasons. And for us, it's the new economy. It's the new way of doing business. It's a green economy, but it's also a new way of providing a lot of jobs. Just ourselves, we're going to be employing close to 1,000 employees just in the next 2 to 3 years in the province of Quebec. But we're going to also hire 1,000 employees in the United States, all across North America. So, obviously legislation is helping, to move forward. But even without the subsidies, the electric vehicle business model makes sense.
And at the end of life, Michael, I mean, Europe has sort of coming to, I think the OEMs, I know China has said the OEM is responsible for the end of life of a pack when it's done. Europe very much seems like they're heading in that direction. Is that what you see going on in North America? And is that going to be a problem?
Yeah, you kind of stole my thunder there, Ken, on the recycling bit. But can I just go back just to add to the last discussion just a minute, and then I'll get to the recycling question. Is that you asked the other guys about setting up supply chains, and automotive OEMs, that's kind of what we do, right? We have 100 years of experience setting up and developing and optimizing supply chains. So what we're hoping to do is bring that experience and that rigor into the battery supply chain business, which we've seen right now is not necessarily optimized. It's still in that very early growth phase. So we hope to work with our partner LG Chem to optimize those supply chains, develop them in the U.S. And recycling is absolutely a vital part of that. We fully expect regulation on end of life for batteries. So we absolutely think that there's a responsibility in industry, whether it's battery manufacturers, whether it's OEMs. There's kind of this shared responsibility to recycle as much of those or reuse as much of that battery as possible. So there's potentially second uses of those batteries, as they retain roughly 70% of their energy storage capacity at the end of life in a vehicle. But that it's still very early days for that recycling industry, right? Vehicles are just beginning to trickle in. And we think it might take some sort of industry consortium at some point to get that early scale in the recycling business in order to make it economically viable. The whole idea about recycling is how can we make it economically viable so it makes much more sense to recycle that battery instead of it winding up in a landfill. That's the best way to encourage recycling, is to make it an economically viable industry.
Also seems that General Motors said they'll be making their own lithium solid state batteries in a few years. So exciting. Now, Adrian, or Adam, actually, I'm sorry. Could you please, I read so many different green sites that say recycle, well, you don't need to mine, we don't need to be so dirty, because we can just recycle everything and produce 30, 40 million vehicles a year. Can you please explain to people how
why that isn't the
will
case?
continue to be an integral part of this value chain?
Well, yeah, I mean, if you just think about it from the very top level, that at the moment, you've probably had about 6 million vehicles pass through in terms of sales since this market started. Now, in 5 years' time, you're going to be seeing probably 10 million a year coming through the market. So clearly, there's a disconnect between the amount of vehicles that are going to be coming off the road to have battery packs to recycle and those going in. So at any point in the next decade or 2 decades, you're going to have more vehicles being sold than coming off the road. So you're always going to need to mine to get that material in. The other point I'd just make about the recycling piece as well, and Michael touched on it, is the fact that you've got vehicles trickling off now, but the batteries coming out of those vehicles now are not going to bear very much resemblance to the ones coming out of the vehicles in 10 years' time. So from a scaling point of view on the recycling piece, you're effectively going to be dealing with different technologies in the next couple of years, and then towards the end of the decade, another set of technologies when the real volume comes. So building scale is going to be quite difficult. And I think it is going to need some sort of intervention, either at the state level or at an industry level, to make that viable. But I mean, with regards to the circular economy piece, yeah, the amount of inputs we need is much greater than the outputs coming off the market at the moment. So mining is going to be around for the next 20 years at least in this market, I would say.
Now, because of that, and you did talk about scarcity of materials, what is your advice to OEMs, to cell manufacturers, to those up and down that value chain about securing raw materials? Should they be letting their partner do it? Should they be trying to, are you so nervous about supplies? Should OEMs step up like publicly Volkswagen has done, and it seems Tesla is doing, to lock in raw material streams? What is your advice to how to handle the tightness that could occur in these markets?
I think a lot of that depends on your scale and where you position yourself in this market going forward. So take someone like Volkswagen. They've obviously made very big bets on this from a CapEx point of view in terms of re-gearing some of their facilities and retraining staff and so on. So they would be well advised to do what they're doing, which is take positions in those markets at an earlier stage as possible and secure material on behalf of their partners. If you're operating at maybe a slightly smaller scale, that's probably not viable just in terms of the upfront cost of that, and that you may be better advised to work through some of your partners who have the scale and can negotiate probably better on your behalf than you could directly with a raw material supplier. Obviously, you're opening yourself up to quite a bit of risk as well in terms of pricing and so on. But yeah, I think it's the scale of the investment you would need to make to secure anything like the level of supplies you would need. Really, the only justification for that is if you're operating at a large scale in this market, or you intend to in the future.
And Adrian, how is Bolloré looking at this? QuantumScape claims they are going to be using a lithium metal anode. General Motors said specifically in their press release they would be using a lithium metal anode. From what I understand, like, it's an incredibly small amount of lithium metal that is being produced in the world today. How do you lock up those supplies for your product?
Yeah, so and just to be clear, our solid state battery has been deployed in thousands of cars, buses, and trucks all over the world, propelling all these vehicles more than 300 million kilometers globally. So again, so we started with the design, and we tried to do a design that is sustainable, and we have develop a patented process to be able to recover. Our target is more than 90% of the lithium out of our cells. We believe that we're going to be on target. Many of these vehicles that are out there, even the stationary products that we have, will be coming to the end of life in a few years. So that's one of the aspects that we rely on the sustainability, the life cycle, the ability to recycle the whole product itself. As I said before, in parallel, from a supply chain point of view, we consider ourselves one of the largest buyers of lithium metal. So we've been doing this. This is the third generation of our products, so we're not new to these. The QuantumScape, for example, or similar companies, their product currently, if you look and sort of like peel the onion and look closely at the product itself, has been developed at a very small scale. We're already industrialized. We have a capacity up to 1.5 gigawatt hours between the two factories. So we have been able to scale it. And one of the issues with solid state, particularly using lithium metal and using the solid electrolytes, is not in producing a battery, it's in scaling it so you can have the yields that you need in order to meet the expectations, say, of a General Motors or a Lion Electric, for example. So we've achieved that, and we look at it from a whole life cycle point of view. So the sources is one, the avoidance of some of these materials that may be difficult is another one, and then the design of the battery is very key as well.
And Patrick, I mean, the changes for batteries are becoming so fast and furious. I mean, Tesla's even using a much larger cell. They're going to start using, you do hear about all these other battery technologies. How do you decide which battery you're going to use and which product and when? You know, because it has to be tested. And how do you sort of decide where you want to upgrade your technology to sell your product?
Well, I mean, the battery manufacturers are improving the capacity of their raw cells, and then our approach is really to capture and to continually technology that advances for the benefits of our customers. Obviously, we look at what's up, available and what we could fit into our different battery packs, and that we could assemble them and to make sure that we're going to be able to perform as the best that we can. 4 years ago, we could only do 100, about 55 miles with a school bus. And today we do 155 miles. Our commercial truck goes up to 250 miles. So technology is advancing fast. And it's also one of the reasons why we've decided to be cell agnostic and assemble our own module and go with our own battery packs. Because, there's too many companies which are specialized into that. So we looked at and worked together with them to make sure that we have, the best material and then we're able to test them also on our different vehicles. So it's fun for us to work in partnerships with the different tier one, cells manufacturing companies. So we're able to see and improve the capacity of the batteries on our different trucks, and it's exciting for the future.
Michael, I mean, one of the things I always find interesting is what Tesla is doing is almost harkening back to what Ford did 100 years ago, where they controlled the entire stream. They had their own steel mill, they had their own glass factory, they had their own plastics plants. They did everything and they own their own mines. You have to set up a pretty much new value chain, but that value chain is going to rapidly change. Like, can you set up a value chain to buy raw materials, especially if you do think certain raw materials are going to be really tight, when you don't know in 5 years what the value chain is even going to be?
No, you're exactly right. And Adam's point about the technology improving on the recycling side and what's the value of cobalt in 6 years that's extracted from a battery, that absolutely applies kind of across this entire issue. Is how do you kind of build the plane while you're flying it, to use a metaphor. You're trying to create these value chains, but we also know that batteries are likely always going to have lithium. At least at this point, as far out as we can see. They'll also likely have nickel, right? And so there's a couple of these materials that you can make pretty good bets on. But you're right. All of and I'll speak for all of the kind of large automotive OEMs. We're all trying to figure out how deeply vertically integrated we want to get into these value chains. With these, with the battery manufacturers, right? And we're trying to figure out giving us both the lowest cost the highest energy density, but also the maximum optionality for the future. So that those are, we're all trying to figure this out, you know, kind of again, as this industry is exploding, and try and protect for the future. What we do know, you know, from an automotive side, we know consumers always want more range. They always want less temperature and climate sensitivity. They always want more utility. Those things don't change. The customer needs, I'll say they're evolving a little bit, but they really don't change. So we have to, you know, set up our business to be on the leading edge of meeting those needs at the lowest cost, for the future. And it's different for every OEM. They all have different strategies. You know, when you see our Hummer EV, we think there's a market for that GMC Hummer EV with a range of up to 350 miles, and that utility, we see a market there. But the market is large, and and so we have to make something for every pocketbook, whether it's a Bolt EV at you know $35,000, or whether that's that Hummer EV more towards the higher end of the price range. So yeah, I think we're all trying to figure it out, and again, provide that optionality for future technology, because I think lithium metal anode might not be the end state, right? There's something beyond that, and we have to quickly react to whatever that's going to be. Make sure we can put it safely and profitably into our vehicles.
Yeah, I mean, every year we survey on average 15,000 consumers. We've done this for 7 years now, on what do they look for in an EV? What do they want to see? And what's been interesting to us is really zero change in what people say to us. And it's whether you're in Norway or whether you're in Canada or the US or Tokyo or China. Number one is range, number two is recharge time, and number three is cost. And it's been consistent again and again and again. And we have arguments, particularly with our European counterparts, who say, no, people need to change their habits. They need to realize they only drive so many kilometers a day, and therefore, you know, they don't need all of that excess energy collected around with them. And we say, look, there's 100 and some years of internal combustion engine history that shows you the range and the recharge chain you expect. And so the industry needs to change for the consumer rather than the consumer changing for the industry. And so I think that's, you know, where this is all heading. As Patrick said, as Adrian is saying, you know, things are just getting better and better and better. But I think the difficult thing for all of these OEMs, and Adam, if you could chime in, how should these OEMs act to probably some difficulty in buying raw materials, particularly high quality raw materials? Should it be the OEMs who are the ones setting up these value chains, like they did with, you know, GM buys their steel and buys their aluminum, and then they have their third-party forces, they're told process it for them, but they really control the big buys? Or will it be the cell people, who we don't hear too much about, cell people tying up long-term raw material commitments? How do you think this value chain eventually plays out?
I think that with the use of the word eventually is telling there, because at the moment, I'd say OEMs have got their hands full trying to adapt to you know, multiple moving pieces in this, and tying up a raw material supply chain and raw materials they're not necessarily used to dealing with is quite a lot to ask, maybe in the near term. I think as time goes on and the volumes go up, then again, it will be a function of scale. So if you're heavily invested in this market as an OEM and you're producing 5 to 10 million vehicles a year, then, you know, I think it's critical that you have some skin in the game when it comes to the raw material piece and about the supply chain. If you're turning out 250,000 vehicles, maybe that's not as important for you, and you can go through your partners. Just wanted to raise one other piece as well, is that the market is changing in terms of the range of chemistries that are coming on. So if you take China as sort of the leading force in this, what you're seeing is there that the market is becoming quite diversified in terms of the types of vehicles coming in. And as a result of that, the range of chemistries being deployed is really starting to spread. So got LFP coming back in at the micro compact level, but also NCM 811 picking up faster in China than anywhere else in the world. And I'd expect that to translate to Europe and then North America maybe later in the coming years as well. So it's not just going to be handling one set of materials, it's going to be handling different sets of materials, different types of vehicles in the product offering. So it's going to be very, very complex. And that's why I think in the near term, there's probably other priorities that are more pressing for OEMs. moving over some of their production facilities, securing cell supply, and then stepping into the raw material market as the volume grows, maybe the way to do it. But again, I think it is a function of scale as to what extent they take investments in those places.
We've seen rare earth prices. If you haven't looked at particularly magnets for vehicles, those rare earth prices have absolutely exploded again. I think they've almost doubled, if not tripled in some cases this year for certain materials. Adrian, I know you say you have a rare earth free system. I think that's what you said. But how closely do you follow prices, and how much are you interested in your raw material flows? Or is it such a small component of the overall the cost that it doesn't matter so much?
Yeah, a great question. Actually, I want to align my answer with both Adam and Michael in a couple of things that they have discussed. So first of all, the way that we see the market shaping up is you have different batteries for different applications. So the battery for a Tesla car, to name one, is very different than, say, for a truck, right? We have been looking at continuously improving the product itself. So for example, the third generation product that we have today is going to be much more energy dense by the end of next year by about 25% to 28% more, right? So that in essence will allow us to require less material, if you will, to some extent for each of these units, right? And that it's already giving us a range. Our buses that are propelled with our batteries are already having a range of about 250 miles or even close to 300 miles. So in terms of securing the supply chain, I mean, we'll be delighted to align ourselves with an OEM, call it a GM or somebody like that, where we can align basically both our goals, right, and be able to source it, secure not only the supply, but also given the sheer volume, right, of production that will come on the back end, be able to continue to work towards improving on the cost of it. So we're open to that. We have our own, our company is very large and has been involved in the transportation of minerals. So we have a very good understanding of the cost of the minerals and the value chain. But we're always open to working with in partnerships with say the GM of the world.
And Patrick, how are you looking at the prices of your raw materials, and how do you look at this in terms of your long-term procurement needs? Again, when you see a cobalt a couple of years ago go up, many-fold, when you see rare earths start to head up many-fold, and we've historically seen some really crazy markets in there, how does that sort of change your view on how you look at your battery raw material supply chain? Or again, is that a relatively small part of the overall purchase price, and it's really the cell manufacturer who's going to have to deal with that?
The biggest enemy of electrification of transportation is cost. The difference between for us, diesel and electric is huge, and it comes over almost 50% of the costs are the batteries. And then we know that, we think that with time, as we're going to be ordering more and more and more, costs will come down. And as there are going to be more people working into the industry and the supply chain, that it's going to help us out. But there's two things really important for that. It's also quality and availability, because, as Michael was saying earlier, after price, it's range. And for us, to be able to make sure that we have a good available range, but we need quality material. And then we need to also to be able to promise, range, yes, but how long will the range, will work, because in 5 to 8, 10, 12 years from now, if you're losing too much capacity on your batteries, then it's not better for yourselves. So, costs, yes, and quality are really important. And then I guess volume will bring down cost of the batteries. But yes, we need to all work together to see how we could bring the cost down. It's really important for us.
Okay, I see we're almost running out of time, so I just wanted to do sort of a quick run through with everybody in terms of 5 years from now. Where will be cost on average at the cell level? And do you think the market is currently over optimistic or not optimistic enough about the adoption of these battery technologies? Adam, I'll start with you.
So in terms of price for these cells, I wouldn't want to be held to this, but I'd say maybe in 5 years' time, you could be looking at about $95 per kilowatt hour. I think maybe slightly lower than that, given the rate of decline over the last, well, you know, five years. I think that decline starts to, you know, the rate of decline starts to go down as the economies of scale get eaten up. But I'd go at 95, maybe lower, maybe towards 90. And then in terms of optimism, prior to this year, I would have said that people pretty much had a good handle on this. But I'd say given the response, especially in Europe, it's probably less the case in North America, but particularly in Europe, of markets within this COVID piece, the rate of growth and the level of government support for these markets suggests that we may be being slightly bearish up until this point. I think actually the next 5 years could really see significant growth. And in the US specifically, I mean, if you track the tax credit that Michael referred to earlier, that GM and Tesla were receiving, track that against sales, and massive influence on the number of sales, particularly for Tesla. That if a Biden administration means that tax credit gets reintroduced without a cap on the volumes, it could grow very, very quickly in the US as well. So I think the upside risk is stronger than the downside risk at this point.
Michael, music to your ears. Do you sort of agree?
Yeah, Adam, I think I agree with kind of the range of battery cell cost of $90 or $95 at a cell level. But let's just do a little math for a second. At a pack level for a 300-mile SUV, that's still an $8,000 or $9,000 battery. Okay, that's probably close to double some sort of internal combustion engine estimate. So we're getting there. In fact, I wish some of the forecasts that we see that always start in 2010. Adam, you probably get frustrated at this too. They always start in 2010. I want them to start in 2015 now, because that asymptote is what we're really talking about now. Whether it's 100, whether it's 80, or whether it's 70 or wherever. But I think absolutely when the costs are coming down, the point at which you can be margin positive on a vehicle, the price point is coming down. So we do expect in the next 5 years a substantial growth in the EV market, not only in the US, of course, but around the world. And again, we were encouraged from the signs we're seeing from the new administration in terms of support for electric vehicle manufacturing and sales.
Patrick? Patrick, I was wondering if you had anything to add on where you think costs are going to be heading, and I assume you're just going public. You're going to be pretty optimistic, otherwise.
No, I totally agree. I think that within 5 years from now, we say our costs are going to go down 50%. So we always say from 5 to 7 years from now, our vehicle is going to be at the same price as diesel, but with all the advantages that we have. You know, technology is moving forward, and it is very expensive as of today, but you know, as time goes by, you know, and with the, you know, also capacity, but it's volume, you know, demands, and as more demand that there will be, price will go down. More people are going to get involved in producing, you know, raw material, and this is what we would like to, and then you know, to be able to get the raw material, assemble that into the battery packs and EV, and the market also is going to grow. And as Michael was saying, you know, with the new administration in place, you know, to favor electrification, and also as people realizing that you know, it's the economy of tomorrow. So we strongly believe that prices are going to go down, and vehicles are going to be more affordable very, very shortly.
And Adrian, I know you look at cost a little bit differently because it's a total cost package, but do you continue to see a pretty steep decline in cost?
Yeah, thank you. Yes, we do. And actually, yeah, I'm glad that you reframe the question, because everybody thinks lithium ion is all that it exists. And when you look at it, for example, a solid state, just for our viewers, there's no need for cooling. So the systems is much simpler. So when you look at the total cost of the vehicle, the contribution of the solid state battery in this case, or the lithium ion, it will continue to go down. And we believe again, when you look and you incorporate the supply chain, the recycling aspects of it, for example, and also if you can limit the amount of raw materials that are not impacted by politics or faraway places, uncertainties, if you will, then we think that the future is bright. We can see in 5 years there will be probably some of our competitors will have a product. Obviously, we have a better product, but we can see that it's a very bright future for actually all of us involved here and the consumer.
Just to give McKinsey view, our base case is in the high 80s. In our aggressive case, and I am an optimistic person, so I'll tell you where I believe is in the $65 to $75 range. And I must say, over the last 6 years, we have continually been surprised on the upside, meaning on the downside of cost. So I think a lot depends on what the technology flows through, but seeing a lot of these new technologies up close, I think we're in good standing. So with that, I'd like to thank our panel very much for this very good discussion. On the last page, which I think will be shown now, yes, there we go. You can see all of our contact information. Please reach out to anybody here on the panel, myself included, and you can ask any further questions that you have. So I'd just like to thank again all of our sponsors, and hopefully this was an informative discussion. And thank you, panels, very, very much.
Thank you. Really enjoyed it. Thanks, everybody.
Thanks, everyone.
Thanks a lot.
Thank you very much. Thank you.